Alright, hopefully we're live. Come on. Come on. I think that means we're live. Finally. Finally. Alright. Open up chat here. Turn down mute. And we're ready to go. Alright. Again, we always start with talking to myself, but I have trust in you guys. Hopefully it picks up later. But yeah, the grand finale of the IMO season. IMO Day 2. The only exam more important than IMO Day 1. And a quick update. So I was reading solutions yesterday after the live stream. And yeah. So as it turns out, I fake solved the the lower bound for P3 live on a stream. So like essentially what I did was we had the right algorithm, but unfortunately I just applied it too early. There was an extra step I needed to do before applying it. So I'm only gonna give myself the marks for the construction, and I'm guessing that's gonna be something like 2 marks because it was probably easier. The construction plus proving it, so yeah. We'll call it a 772 on day 1. And yeah. Now I've got the day 2 paper. This time I went to Shanghai, took a member of the UAE team hostage, and got them to give me their day 2 paper. So yeah. Without delaying it any longer, let's do it. And okay, should probably start things off by saying like this is genuinely my dream paper, guys. I mean, combi question 1, algebra question 2, and number theory P6, number theory question 3 even. Yeah, this is genuinely my dream paper. Oh, we got some chat. Good luck, bro. Thank you. Narain, I've been preparing this summer to take the AMC 10 as an upcoming sophomore. It's my first maths competition. Do you have any advice? The best advice I can give you is, for the time being, it is practice, but you want to practice in the right way. And if you want to know how to practice in the right way, you need to watch my latest video. I think it's something like the best way to get better at maths Olympiads. That is the way to practice. I only found out that way fairly late into my maths Olympiad journey. And I'm sure if I did that in an earlier stage, I would be a lot better right now. So yeah, watch that video if you haven't. Anyways, question 4. Shan Yu and Mulan are playing a game. And in this game, we fix an angle and Shan Yu makes a paper triangle with measurements of his choice. Then they repeatedly perform these steps. If the triangle, so Mulan wants to force the triangle to have an angle theta. Otherwise, so in Mulan's move, okay, let's see. So if we have a triangle like here, in Mulan's move, she can pick a point and has to not be a vertex, and then makes a cut P. So this is P, and this is the opposite vertex. makes a cut like that, and then you get two triangles. The other guy, Shan Yu, he discards one of them, and the remaining triangle becomes a new T. And Milan's goal is to force, so Milan wants theta to exist, and Shan Yu wants theta to not exist. That's the game they're playing. Okay. And you have to find the values of theta that Milan can win. Right. I think the first thing we want to do here is exploit some symmetry. So if we can force the same angle to appear in both triangles, then Milan wins. Like if theta appears in both, that's when Milan wins. And one easy way to do this is by dropping perpendiculars. So if we can draw the perpendicular here, that's 90 degrees. That's 90 degrees. Milan wins. So Milan can win for 90 degrees. Yeah. And another way is if you have an angle, and so you got like so this is the angle, and you got theta here, and you got some other angle R, then if Milan makes this cut, the next guy is forced to choose this triangle. And we can keep on doing this until we get to 2 theta. So essentially, if we have a multiple of theta here, then then we're good. And so Milan actually wins if there is a multiple of theta, and Shan Yu wins if there's never a multiple of theta. It doesn't have to be just theta. But now, oh, that's actually pretty easy. That's pretty easy because yeah, in any triangle can have like a lot of angles. There's a lot of variance with the angles that a triangle can have. Got alpha, beta, gamma. But the angle of the side, this is the key step right now, guys. The angle of this side is always 180. So in some sense, there's always an angle of 180. Now, we have this cut, and we can make, let's say this is theta, and this is 180 minus theta. Now, if this is a multiple of theta, we win. And so it follows that any theta such that n theta equals 180, or in other words, theta equals 180 of n, Milan can win. That's cool. So Milan can win when theta is 180 over n. Yeah, that's we still have to prove. I was almost gonna move on, but we still have to prove that Shan Yu can win if theta is something else. And so yeah, we just want to show that Shan Yu can make it so that no angle is a multiple of theta. Let's see. I have very little interest in higher level math, but the video you uploaded in 9 days was fire. Thanks for the masterpiece. No, thank you for watching my video. Thank you. It means a lot. Hello. My geometry's weak. What can I do? I've actually got some good advice for this. I'll make a video on mindset. But see, my geometry is also not that great. Or at least I thought, right? And yesterday, as I was trying the questions, I just assumed that question 2 had to be really easy. Like, I genuinely believed with all of my heart, question 2 is very easy. Because I can't do normal IMO question 2 geometry that often. So I had to believe in my head that it was easy for the live stream. right? Like I've solved most IMO question 2 geometries, but not in a not in a sort of not in a exam. I've never solved like that difficulty in an exam. So when I yeah, so a good way to get better at geometry, I'll stop the app, is just believe that you're gonna solve it before you do it. Because as it turned out, the geometry question from yesterday, the IMO P2, apparently was very hard. But if you just believe you're gonna solve it, you will probably have a much better chance at solving it. I can't lie, your channel has really motivated me to try and reach the IMO. Best of luck, man, and best of luck to you too. Aspiring quant here. What tips do you give me? Um, not gonna lie, I don't know if I want to be a quant, so I can't really give you tips on that. I can't even comprehend what you wrote. Yeah, that's my fault. Okay, but essentially, back to the question, we wanted to show that Shan Yu can force a multiple of make it so that a multiple of theta never appears, and the way he can, okay, so he can pick a triangle such that there's no multiple of theta, and let's say guy makes a cut. I'm doing question 4 right now. Resin J6F. Yeah, I'm doing question 4. Let's say he makes a cut. So this triangle, that's a Bond's pen. This triangle has no multiples of theta. No k times theta. And so so this can't be a multiple, this can't be a multiple. So any multiples are among these 4 angles right here. If these 2 are multiples, then theta equals 180 over n. So theta, but we're saying here that theta is not 180 over n for any n. If these 2 are multiples, then that was a multiple. So it must be that this one and this one were multiples. But if this one's a multiple, yeah, okay. If this one's a multiple, this one's a multiple. So this is k theta. This is 180 minus k theta. This is n theta. That means that this must be a multiple of theta, which is a contradiction. So if Shan Yu just picks the right triangle, which he can do by shifting the angle slightly, he can force it such that no multiple of theta ever appears. And if no multiple of theta ever appears, no theta will ever appear. So that's question 4. Question 4 done. Honestly, not that pretty straightforward. I think it's kind of immediate from like dropping puppet and I don't know. It's a cool answer, and I guess it's a good question. Yeah. Anyways, how long are we into the stream? How long did that take? Oh. That took us 15 minutes. Are these problems online? Yes, they are, but I can show you the paper right now. Yep. This is IMO Day 2. The paper is online though. If you go to Art of Problem Solving, Art of Problem Solving will have the IMO paper on the website. Right. Problem 5. It's okay, it's a functional inequality, and we can see right here that, in case you don't know, so this is the geometric mean. If we just say like f of y is y, this is the geometric mean. This is the arithmetic mean, and this is the quadratic mean. So we want a function that obeys the QM, AM, GM inequality. This is like a well-known inequality. So yeah, I think the first thing we want to do is make stuff cancel, right? Because again, so if I'm being honest, my first thought here was to do something analysis based. But this is the IMO. And one thing you should keep in mind about the IMO is that they never have any analytical questions. Hey, Narain, can you answer my question, please? So, I was a grade 11 student. I have no prior experience in Olympiads. We are having a regional. Oh, yes, IOQM, sure. How should I prepare? So, if you have no experience, you need to practice that paper. So, but you also want to practice that paper along with easy Olympiad questions. And, yeah, like the best way for you would be to do IOQM and RMO at the same time. Because I think RMO is especially the earlier questions, they're very entry level Olympiad, I think. So that's what I would advise to you. Sorry, which papers? India does RMO, I think. Regional Maths Olympiad. So that's the next round. So you want to practice, if you have no experience, you want to practice IOQM and RMO kind of at the same time, is what I would suggest. Anyways, so this is one side. This f of x plus y is the middle, and then so yeah, my first thought was to do some analysis because there seems to be like some contradiction by the size of f of x compared to x and f of y compared to y. But I'm not sure if that's the way to go, to be honest. Because it is the IMO, and the IMO tends to avoid very technical solutions to problems. There's always going to be a simple solution. And for FEs, the main thing we want to think about is, hold on. Come on. The main thing we want to think about is the motto for FEs. And for FEs, we just want stuff to cancel. And so what's the bad stuff in this question? It's the square roots. Like the square roots are very annoying, especially we have a square root compared to a linear function. So if we want to make it cancel, we can make it a square in the side and turn it into something linear. So the best way to do this would be to set x equals f of y. And notice that both sides here become f of y. And the middle, so the middle becomes f of y plus y over 2. That's what the middle becomes. And yeah. So notice like the left and the right, they are they're the same, which means that these inequalities, they're actually equalities. And it follows that f of y is f squared, f of y, plus y. We are going to learn anything from this guy. Man, I'm sorry to hear that, bro. Sorry you feel that way. Could I also have advice, please? I'm just beginning, but by the next few years, I want to do well in BMO too. Should I just do questions with the correct difficulties? I think that really depends on how good you are. How good are you at BMO 1? Because up to BMO 1 question 3, it's just practice. So, yeah. That's... After BMO 1 question 3, you can probably start putting in books like IMO, other stuff. But yeah, that's all I have to say. Bro's so busy in changing his voice tone. I guess, man, if that's your takeaway from the stream, then love to hear it. f of y is the average of these two. So any f, okay, that's interesting, because I was thinking that the only functions that work are going to be fixed points. But it seems, so when you have this sort of this rearranges to give us that the difference in like a chain of y remains constant. So f of y minus f of y equals f of y minus y. Okay. Yeah, so that really makes us consider f of y could be y plus c. Could it though? I mean, we can try it. So that becomes y plus c over 2. That would be less than, that becomes, x plus y over 2 plus c over 2. And then this is x times y plus c, which by difference of two squares is always going to be less. And yeah, this one becomes x squared plus y squared plus 2cy plus c squared over 2. And if we square this one, then we get x plus y over 2 squared plus x plus y c over 4 plus c squared over 4. Oh, mate. It's so hot in UK right now. It's out of battery. Oh well, suffering the heat. X plus y over 2 squared. Oh, dang. Okay. Is that inequality true? Because if it is true, then, yeah, then it might be, we just might be onto something. Also, last doubt, should I study the topics or keep solving questions and look up the solution after not being able to solve them, as we aren't yet introduced to combinatorics, pigeonhole, in India. Yeah, so solve questions, and if something that you haven't seen before comes up, you can look into that topic, because that topic is at the level you should be practicing at, which means you should know it. If yeah, so only, I think, because you said, if I'm not wrong, you said that you just started, so I think that, you don't need to go in learning theory right away. You start with doing questions and seeing what theory you need for the questions, by reading solutions if you can't solve it. Okay. Is that true? I hate questions with so much algebra. So we can multiply out by 4 to get 2. To get that, I guess. No, wait, what? Yeah. To get x squared plus y squared times 2 plus 4cy plus 2c squared. And this gives us x squared plus y squared plus 2xy plus x plus y times c over 4 and then that would be hold on, that would be c squared. No, that's not over 4. That's just that. So, I mean, so all we want is if you rearrange this, I think it has to be a fixed point. It's got to be. Plus c squared plus 4y minus, 3y minus x times c. Is that right? Yeah, that's right. So if x is like much bigger than y, if x is like much bigger than y, then that, we know, I didn't read, x minus y squared plus, take out the y minus x, c, then get plus 2yc plus c squared. Okay. Oh, fine. So if x minus y is, so this only has a possibility of being negative if x is bigger than y. But, wait. Yeah, this only has a possibility of being negative if x is bigger than y. So if x minus y is d, then if d is more than c, then this takes care of this. If d is less than c, then this takes care of this. So either way, this is always more than or equal to 0. So, yep. I was wrong, and f of x equals x plus c is the solution. So I guess now we just want to show that in these chains, which makes our solution path a lot easier, because now we know basically these stuff, and this is a technique, which I know I've said this like 20 times in the past, in this stream, in the last stream, but this is a technique that I will make a video on. It's called arrows, okay? And I don't think it's used, it's going to be used too much in here, but essentially it's looking at, when you have a functional equation, it's looking at chains of the functional equation. So it's imagining, you might have seen those functional machines way back in, I don't know, when you were 11 in school. Like you put in x and you get out f of x. So arrows is just taking a chain and looking at the behavior of it. And we only use it we only touch upon the technique here because we take the chain and we look at the behavior of the chain. And yeah, we have that each chain is an arithmetic progression. But we now want to suppose that there are two chains that, so these two chains are arithmetic progressions, but we want to suppose that they have a different common difference. And yeah, see how we go. So I guess we can let one of the offsets. Also, what the chain gives us is that, first of all, so the common difference is more than or equal to 0. Could even, yeah, it could be 0. Or okay, so let's just see. So if we take 2x and y, f of x equals x plus d1, f of y equals y plus d2, we want to show that d1 equals d2. That's our plan. And to do this, how do we do this? Guess we just plug them in. So okay, this is a lot easier on paper, but I'll do it on mouse. Oh, that's pretty close. So again, f of x equals x plus d1, zoom out a little bit, and f of y equals x plus d2. So I'm gonna try and be neat. I'm gonna just type it out, can't be asked. Okay. So then this one, and wait, what was the question? So it's just x on its own, so x squared plus y squared plus 2, I'll just call it a and b actually, so y would be b, 2by plus b squared, all over 2. We'll just times 0.5, and then, oh, we got formulas actually, so I can do that. Hold on, I'm gonna redraft this. 0.5 times x squared plus y squared plus 2by plus b squared. So now we're gonna square things out, and yeah, so we squared the left hand side, we're squaring the middle hand side, and that gives us, so 0.25 times x squared plus y squared plus a squared plus 2ax plus 2ay plus 2xy. And that's then squaring this one just gives us, plain and simple, x times y plus b, or xy plus xb. So then multiplying out, this becomes a 1, this becomes, so 2y squared, and it was 2, so it's 4by now, and 2b squared. Okay. So how do we cope with this? Well, okay. First things first, if Yeah, hold on. So if b is more than a, then we can also make y more than x just by, you know, increasing y, following the chain. And then yeah, this thing just can't be true. I think that's correct, no? Yeah, that can't be true because do we even need this side? I think this side is just to give us the arithmetic progression. But that can't be true because look, shift x squared y squared into xy to the other side. We get x minus p4 already done. Yeah, p4 already done. Plus 4by minus 2ax minus 2ay plus 2b squared minus a squared. Hello, Shivansh. And yeah, so look, if b is more than a, then we can make y more than x by increasing y. So if y is less than x, replace it with f of y. If that's less than x, replace that with f of y, and so on until you get what you want. So that's non-negative. B is more than a, and y is more than x. That's non-negative. B is more than a, so that's non-negative. Which no, that's not. I proved it's true, not that it's false. So it's very stupid. Yep, that was silly. Forget that, we're not done. So we want this to be more than or equal to 0. And comparing the other side, we need to make this 4xy and 4bx. So comparing the other side, we get x minus y squared plus 2ax plus 2ay minus 4bx is more than or equal to 0. So what can we deduce? Hold on. Okay, if like y minus x is d, b minus a is e, then this one implies that what is this problem, man? Is there some more work we have to do? Surely not. And if you can share your Instagram with any other contact, I can further take advice if possible if you're willing to help me out. I don't really have social media, no. Fx equals x plus c works. Yep, it does. Man. But this is surely like too much computation for IMO. I don't know. But what other thing can it be? I don't understand. both of these things have to be true. So, okay, if the bottom one is true, then we say like, oh, if B is more than A, I don't know. Yep, I don't know. Okay, so let's say, case 1, A, B are both more than 0. Then we can, and B is more than A. Then we can set X, what days? I'll do it here. So if X is more than Y and B is more than A, then difference is like 4A minus 4B times X. And we can set X minus Y to be less than B or some constant. Basically, this is super big. And yeah. So that, I think we're done. I think we're done with P5 because so 1, there are not 2 positive differences. If there are two differences, namely 0 and D, then so if f of x is the one with 0 and f of y is the one with D, then yeah, there are basically all sufficiently large ones satisfy like f of x equals x plus D. All sufficiently large numbers. And now we just need to prove that if f of x equals D for all x more than m, then that implies it holds for the rest of x. Oh, this is such a Bunce problem, man. It's so bad. Worst IMO P5 of all time. Yeah, I think we just needed this one. Yeah. And I think this is where we use both of them. So x plus D squared plus y squared over 2 square root. Oh yeah, so we can probably use this inequality. Basically, this inequality with a equals 0, does it give us the answer? Hey man, I don't know how to say this. I'm somewhat good at SOC, but I haven't done BMO stuff a lot. I'm year 12 going into year 13. Is it worth spending time doing maths Olympiad now? Well, it depends on what you want to do. Like after school. If you want to do maths, I don't know, man. I would say like focus on STEP, because STEP is really hard. Focus on Cambridge interview questions at this stage. Because honestly, like, there's a lot more. If you just enjoy maths, there is a lot more to maths than pure, Olympiads, right? There is so much more. So, yeah, don't get too bogged down on, oh, I need to do well in Olympiads, because often guys who do well in Olympiads miss out on the joys of maths later. I'm not that good at, currently I'm not that good at, real maths, right? So, find something that, if Olympiads is like really interesting to you, then go for it. But if you're doing it for like glory applications, then I would suggest find another part of maths that you genuinely find interesting. By the way, it is certainly possible to, make it into camps in 1 year. There are some guys, I know some guys. So if you want to make it into the camps, then that's very possible. So that's also not a concern. Anyways, yeah. So if that's, or actually even better, if we set, so y is a fixed point, which means like b would be a fixed point here, and a is the not fixed point. So that becomes 0. And yeah. Oh no, this just gives it. So if a is 0, then we can just make y close. So yeah, if there is a switch from this to f of x equals x, then yeah, we have y, wait, what? Hold on. So okay, b is for y, so we want b to be big, well, like not 0, a to be 0, and yeah. Yeah, so if a is 0 and x and y are close to each other, then this becomes negative. So in other words, we are done with Q5. That was a very bad question. I'd hate it completely. I guess the nice step is with the chains, you can force x minus y squared to be really small. But, isn't that nice, man? It's just a bad question, honestly. I don't like it. But yeah, now, question 6. Question 6. Okay. Turn the volume back down. Right. Go somewhere else. Where's the pen? Good. infinite sequence, so already an S-tier question, and you know what, I should probably write up question 5 because there's a lot of details. So yeah, before we go into question 6, we're gonna question 5 write up, because I know I fake solved question 3 yesterday live on stream because I didn't check through the details. So I'm not gonna do that for question 5. Yeah. Question 5 write up. We have the first thing is f squared y minus f of y equals f of y minus y. So each fk of x is an arithmetic progression. Each f, like the iterated chain of f. So each of that is an arithmetic progression. So now we suppose that there are two different values, like f of x minus x equals a, f of y minus y equals b, and then we plug it back into the original equation. Wait, can you hear the background noise? I don't know if you can, guys. Sounds like you can't. Narain. That's me. That's so ominous. Narain. f of x equals x plus a, f of y equals y plus b. You asked TS yesterday too. Yeah, shoot, bro. I must have missed it. What was it? It's f of y squared, so y plus b squared plus x squared. Is it fine if we can talk once in Gmail? I don't have like a non-personal Gmail, but you can shoot me a LinkedIn DM if you want. That I'll respond to you there as well. It's just I don't have like a Gmail that isn't a personal one. So yeah, y plus b squared plus x squared. All right, one sec. Okay, I'll respond after the stream if that's all right. Y plus b squared plus x squared, and yeah, all that is divided by 2, so 0.5, and we're squaring everything, so that one becomes 0.25 x plus a squared plus y squared. No, that's not true. It becomes x plus a plus y all squared, which is x squared plus a squared plus y squared plus 2ax plus 2ay plus 2xy, and then the geometric mean. Can I shift this somewhere? Hello? Just have to drag my... Okay. And the time for a break. Yeah, cheers, buddy. Which is more than or equal to... And then we had x times f of y in the square root, so xy plus... And we're multiplying by... No, we're not multiplying by 4. xy plus bx. And then multiply by 4 now, and I think all we used was this one, the one with the geometric mean. So multiplying by 4 gives us this, and then rearranging, so 4xy goes to that side, gives us this, a squared plus 2ax plus 2ay minus 4bx. I think we missed out the a squared, and that was the thing holding us back. It wasn't even relevant though. No, it wasn't. No. Because we can basically, if x is, so this proves there are, yeah, this proves not two positive, so at most one positive difference in each chain. Because if there are two b is more than a, which is more than 0, and b was with y, and x was with a, we can force x to be, like, we can increase x to be more than y, and we can increase y until x minus y is less than b. Because we could replace y with f of y and f of y, and so on. And that means that this is almost b squared. It's a squared. So this is like less than or equal to b squared plus a squared, and then y is less than x, so that becomes 4a minus 4b times x, which for large enough x is a CTD. And then from when we have only one difference, that's pretty straightforward, because we proved that for all like small enough x, it follows that, no, sorry, large enough x implies x plus d, and we do the same thing but for the smaller stuff. Proof by contradiction. And that gives us question 5 in the bag. And yeah, that's question 5. Question 6 now. Okay, so wait, where's, I put the score out somewhere, like, just wondering where. Need to keep track. I think it's somewhere up here. Yeah, okay. So as a reminder, IMO day 1, I thought I solved everything, but turns out question 3, I got it wrong. So yeah, so far we're at 2 solves, and yep, that's, we're only 1 hour into this IMO day as well. So it's looking pretty good, in my opinion. And yeah, question 6 is number theory. Let's take a look. So let A1, A2, A3 be an infinite sequence of positive integers greater than 1. Suppose that for all positive integers n, the number an plus 1 is the smallest positive integer greater than an, such that the GCD of an plus 1 with everything that came before it is more than 1. Prove that there exist positive integers t and l such that that is true for every positive integer n. Okay. This reminds you of a question which is like, the question is like, an is the smallest integer that hasn't appeared yet with GCD an minus 1 is more than 1. But this one, the question is like, prove every integer occurs in AN. But this is completely different because that's a very random sequence which depends on the starting value a lot. And this one, there seems to be some structure to it. In particular, what this condition actually means is that the sequence of differences. Wait, so 2, 4, 6, 8 is an example of a sequence. Yeah, 2, 4, 6, 8 works, and you can't have anything different because, let's say you had, so n plus 2 will always be the always have a common factor with everything else, and if n plus 1 did, then you're saying that GCD n and n plus 1 is more than 1, which is a contradiction. But what I was going to say was, what this condition means is that if we consider sequence of differences, so sequence of differences as di equals ai plus 1 minus ai, how do I move this, man? Whatever. Di equals the sequence of differences. So this condition just means that the sequence of differences is periodic. So that's what we want to prove. That this sequence right here is periodic. So the sequence should not contain any prime. Yeah, the sequence can't contain a prime number or a prime power. Is it fine if I get your Gmail and you only answer when you see my Gmail, technically my username on YT2? Again, that's like, it is my personal mail, I'll be honest. Yeah, it is my personal mail. But LinkedIn's fine. I'm open to LinkedIn. If I had social media as well, I would offer that up too. Di equals ai plus 1 minus ai. And yeah, why is it periodic? Well, so if we say that ai plus t minus ai is, so this difference is just the sum of differences, right? And we're saying that it's that's what you call it? That sum, no matter which I we start on, is the same, equals L. Equals L. So it follows that di equals di plus t. So this right here is what we want to prove. And a good way to start with proving a sequence is periodic is prove it's bounded. Okay. And it's bounded because, yeah, it's very obviously bounded actually, because so for any n, there exists p dividing a1 such that p divides an. So if we take yeah, so for any ak, if we have rad of a1, so rad is the product of prime factors dividing ak. Not even, obviously a1 dividing ak also works, so I could just say that, but I'm cool, so I'm saying rad of ak divides rad of A1 divides AK. Then AK is a valid choice. So any multiple of the radical of A1 is a valid choice. But so a multiple of rad A1, so that like rad A1, because I'm not typing it again, rad A1 equal R, then the so if AK equals like LQR plus S, then so S is less than R and more than or equal to 0. Then note that since AK plus 1, Q plus 1 times R is a valid option. Oh, R got deleted. It follows that dk is less than or equal to R. Okay, so now we have proven that there's finitely many options for the differences. All right, thanks. I've got that. Wait, so is a problem equivalent to proving difference rate is periodic? The sequence differences? Yeah, it is. And this is why. So we're given that if the sum of the differences of every t is constant, then so if the sum of every t consecutive differences is constant, we just want to show that two differences like di and di plus t, they are equal. So just prove that. And proving a sequence is periodic is much more simple than proving this. At least I think so. How old is Narain? Narain is 17. Your video is hiding the page? Oh, my bad, guys. Is that better? Should I need to... Oh, I can move it finally. Need more space. Yeah, no, got it. Abi Manjit Nayak, got it. Hi, Narain. How long did it take you to get to BMO 1 round 1 gold level, and when did you start? So I think I started practicing like start of year 8 in UK, and it took me BMO 1 gold. I think I was there like maybe April of year 9. So it took me a year and a half. But then again, I was year 8, so obviously you start like you can start early, but you also start like much stupider. So it does take longer to get good. D Can you explain the rad notation? Okay, so rad is the product of all of the prime factors of A1. So for example, rad of 12 would be 6. And the divides, this one, means A1 is a multiple of P. So, and this is given by the GCD condition. dk, yeah, so it's a bounded sequence, the sequence of differences. But that's pretty... Anything else we can get? Yeah, no problem. Hi, Narain. What advice would you give to an 8th grade watching this video? People have asked me this a lot. Best advice I would give is to go on my channel and to watch my most recent video about the best way to get better at Maths Olympiads. You want to practice, but I show you the right way to practice, pretty much. Whew. Okay. Honestly, like I could just tap out here, take 30 marks, but you know, we can keep it going. I should be able. I back myself to solve this, if I'm being honest. Right. What if S is co-prime to R? Yeah, I mean, it can't be co-prime to R. I think we can establish that. Okay, let's see. We could look at GCD, how AN, A1 vary. Oh no, because we only care about prime factors. So basically, a good way to think about the GCD stuff, which is how we can think about. So that question I mentioned earlier about proving every integer appears in the sequence. A good way, how you think about GCD there is, you know, you just, because the only condition is GCD AN, GCD AN, n plus 1 is more than D. Sorry, more than 1. So, yeah. Except here it's just AI. So basically, n plus 1 and AI are linked by some prime factors. Yeah, that's true. Okay, and hold on. Wait a minute. So that is less than R. So the two guys, GCD n and n plus 1 is always less than or equal to what is it less than or equal to, guys? Yo, Narain, switch the line. Gang, I lock in the dark. It's better. You'll probably not fall asleep then. Yeah, no, maybe that's true. I don't know. It's also very hot. I'm gonna get some water. Hold on. Stupid ass mic. But but the water is not for drinking. I'm gonna put you guys on peak. Is FM really that tough, or people just overreacting? If you're not good at maths, then it's hard. But if you are always like second best, best in your class, then it should be fine. But anyways, this is a peak fan. What you do, open it up, because it gets really hot in the UK summer. Open it up, pour some of that water in. Close it. Plug it in as well. Yeah, make sure it's plugged in. That's pretty important. Hell yeah. Is it too loud or? Yeah. Wait, have you sent me a connection request? If you note, like, you can just search my name up on LinkedIn, it'll probably come up. What team you supporting in World Cup? See, like, had to recover from last night, honestly. You know, I thought we were going to win the World Cup, England. But, yeah. For the final, I guess it's going to have to be Argentina. Like, how can you not support Messi, you know? Anyways, yeah. So the GCD is less than R, which means that they're always linked by prime factors that are less than R. So always linked by prime factors that are less than or equal to R. This fan actually helps so much. It was like 400 rupees from India, something like that. Okay. And yeah, anything but Argentina. Gang, you're not for real. Nah, man. Nah. That's not a valid take. Q, R plus S. And we know that GCD S R is more than or equal to more than 1. So, therefore, we have some choices, I guess. Oh, I don't know, man. I don't know. VA Argentina. Maybe, man. It's not coming up. Are you spelling it right? I don't know. You're spelling it right in chat, so. Yeah, that's my name. That's me. That's strange. GCDSR is more than 1. So importantly, again, I think we can make use of the fact that Q1 plus R is always a valid option, no matter what. This has got to be. This is some pigeonhole. I'm pretty sure it's some pigeonhole. Cause like, look, we have some A. I'll call it TQ equals QR. A T Q plus 1 equals Q plus 1 times R. How many questions you solved from day 1? I solved 1, 2, and I got the construction on question 3. ATQ equals QR, ATQ plus 1 equals Q plus 1 times R. And also it's increasing, bear that in mind. So this value is bounded. Is yeah. Because it increases by at least 1. You can make it strict because it's not QR plus 1. We know that for sure. So that difference is bounded. Wait. And yeah, it's always it just, it feels like you have all the ideas. Like, it feels like I've solved it, but you know, I haven't. Like, the ideas are in my head mathematically, I just can't translate them. I don't know. So ATQ is QR. Okay. I think we can get eventually periodic. But how about periodic? Sent it? Thank you. You should make grinding streams too. Maybe, but honestly, it's very hard to. Actually, that's actually a shout, you know. Because I was gonna say it's very hard to think and do like talk and do maths, but maybe it helps. Like solving 2 questions in 1 hour from the IMO is not too shabby. So maybe talking while doing maths actually does help. I'll consider that, yeah, making grinding streams. So I think we can get eventually periodic. Because, why can we do that? I'm gonna start doing maths too. Love to hear it. Love to hear it. It genuinely feels like we're so close, guys. So, okay, is there a way we can predict this gap size based on predicts based on the value of Q? Well, okay, so if QR is there and Q is a prime, then the next one will be QR plus P. Well, no, S, no. I'm trying to think of a good one. QR plus A, where A is the smallest prime factor of R. Okay. Dude. It might be worth proving that GCD AN AI always has a prime factor smaller than R. Is that a shout? I don't know. Even though I'm 23-year-old, but I love your content. No one told my childhood told me about the world of Maths is deep. I appreciate the support, man. All the best, future quant analyst at Prime Quant Company. Wouldn't go that far. But thank you. I know you, thank you. Hi, Narain, do you have Discord or public email? I'd like to reach out to you. No, but again, my LinkedIn is open. Happy to answer questions on that. The GCD always has a prime factor smaller than R. Is that even true? I think we can CRT a gap. I have a feeling. We can CRT a gap to prove some good stuff. So what am I meaning? Like, so CRT, Chinese remainder theorem. It's not really a theorem, it's just if you have X congruent to A1 AI, A1 mod P1, X congruent to A2 mod P2, and so on. See that? Mod PL, then we can force like there is an X that satisfies all of the above relations. So we can force such an X to exist with anything we want, which is very, very handy, very helpful. So I'm thinking if we CRT a Q so that well, what would be a good way? We haven't even tried small cases. Would small cases help? No, let's go somewhere else to try it. So if we start with say 12, the next one 14, then 16. Okay, if it's even, then game's gone. But say now it's like 15, then 18, then it's 20. Then, because you gotta have GCD with 18, 15, you can't do 22. 22 is not valid. Can we do 20? Can't do 21. That's not valid. Can do 24. That works. And then from 24. So again, we're looking at gaps of 15. 30 appears. 30 has to appear. 24, we can't do 25, 26, 27. This one is 30. And the gap from 15 to 30, so A1, A5. Okay, let's note down the values of which 15 appears. So we have A1 and A5. And now the next one, we're looking, 45 has to appear in this sequence. So from 30, we can go to not 33, but 36. And from 36, we can go to, has to be a multiple of 3, because GCD 15, 18, so it has to be a multiple of 3. Or actually, no, it could be even and a multiple of 5. Because all of these guys are even. So even and a multiple of 5 actually also works. So 40. And does 42 work? Yep, 42 works. Ay, ay, ay. Can we get an even better bound? Because I noticed that it's not bound by 15, it's bounded by 15 and 18. So if you start with A1, then A2 equals A1 plus the smallest prime factor of A1. That's a fact. So if A1 is Kp, then A2 is K plus 1 times P. I don't know. I don't know. Okay, maybe it is something to do with the... Oh yeah, no, if we prove that the... Okay, let's go back. If we prove... So if we prove that the sequence TQ plus 1 minus TQ is periodic, then we are done, because A1 is a multiple of R. So that's all we need. We need to prove that this sequence of differences is periodic, and it only depends on the value. So if we show that TQ plus 1 minus TQ, if we show we can predict it based on what Q is, if Q is congruent to like R mod P or mod N, so yeah, if we show we can predict the value of the difference based on what Q is under some congruence, then we'd be done. Because then it'll be periodic mod N. How much time we spent? Coming out 2 hours. I think if we feel very close, it just will feel so close. Stiff ass neck. Okay, so let's say in this sequence, let's go back to normal, like what we were trying to prove earlier. We want to show that this always has a prime factor less than R. God damn. Always is a prime factor less than R. So, hey guys, what can I do after Algebra Calc 3 and a bit of real analysis later? I'll let chat answer that one. Always is a prime factor less than R. So this is something we want to prove. And the reason we want to do this is because it makes characterizing, when we characterize like how the sequence behaves in the gap between QR and Q plus 1R, it makes characterizing it a lot easier because we don't have to worry about prime factors that are bigger than R. So yeah, GCD, AN, AI always is a prime factor lesson R. Oh my days. Ay, ay, ay. Write some stuff down. So, actually, can I do it there? Probably can. So P divides AN. P also divides AI. Thoughts on this year's IMO problems, at least to what you solved. So I solved 1 and 2. I thought 1 and 2 were amazing. 1 is one of the best question ones ever, and so is 2. 3, I think, as well, is really nice, but unfortunately, I fake solved it on stream. So, yeah, that was funny. But 3, after reading the solution, I think is also an incredible problem. Question 4, it's okay. It's like, it's fun, I guess. Question 5, I really don't like. But it's not as bad as the year before. And yeah, right now we're doing question 6, which so far is pretty alright. Are you from the UK? Yeah, I'm from the UK. You can't solve IMO 3.6. It's about belief. Self-belief. Like, so much about maths is about... Wait, hold on, guys. Hold on, guys. Yeah, sorry about that. My dad's work from home today, and there's a very intense meeting, I guess.
On the dust recovery
But
part where we are saying
oh,
it is 96.67,
well,
assuming we are collecting
I think we should be good again. I don't know. Anyways, moving swiftly on from that. Suppose that we have P divides AN, P divides AI. Yeah, so we wanted to show that there's always a prime factor less than R in the GCD. Okay. P divides what? I don't know. I don't even know. Okay, so we know that AI has a prime factor smaller than R. Okay. I think I have something. Might be useful. So both of these guys have prime factors that are smaller than R. So if R divides, so like maybe R divides AN and S divides AI. So we can pick something later. Like wait, what am I saying? Why is he just talking? Damn. Okay, let's keep it simpler. How about we just prove that DI is eventually periodic. Let's do that. So we want to show DI is eventually periodic, and from there we want to show DI is periodic. So okay, after some point all all prime factors like so. Let's P be the set of prime factors less than R, and S be the subsets of P that contains only primes dividing a term in the sequence. I'll move this a little bit. So, okay. As it happens, so, wait, hold on. Eventually, actually, this is some long ass sentence. Eventually, so you guys remember what S is. Eventually, the size of S is constant. So no new small prime factors appear in the sequence. Just appear in the sequence. Ooh, man. Man. Ay, ay, ay. Time for a break again. But no, we keep on pushing. About like a roadblock right now. I think we were cooking with the multiples appearing. Maybe some pigeonhole? I don't know. I don't know. Or, instead of proving that two stuff are the same, so essentially, we want to show that, like after some time, how the sequence behaves between QR and Q plus 1R is the same. But so we can encode the sequence of differences in a tuple, SQ. So that'll be DTQ all the way up to DTQ plus 1 minus 1. And so first of all, the size of SQ, the size of SQ, come on, give me it. Guys, SQ size is bounded by R, and each of the differences is also bounded. So, finitely many SQ, there is, but it's an infinite sequence, infinitely many Q. So, by infinite pigeonhole principle, there is an SQ occurring infinitely often. So we can look at that SQ, and then from that, oh man, from that we can maybe show that if SQ equals no, hold on, SQ equals ST, then SQ minus 1 equals ST minus 1. And the same with SQ plus 1 equals ST plus 1. And then we'd be done, because then the sequence of differences would be periodic. And how do we do that? How do we do that? Oh, I'll write some stuff down, man. So, actually, we'll do a small example. So we can start with 9, 12, and then tempted to say 14, but it has to be 15. Or actually, no, 9 is a bad example. Let's start with 30. Now, so our working R is 30, and we want to see how it behaves from 30 to 60. So we got 30, 32, 34, 30, okay, if it's even, then My days. If it's even, then there's no problem. No problem at all. Okay, how about we have QR and TR, and then QR plus S1, TR plus S2, then QR plus S1 plus S2, and TR plus S1 plus S2. So always S has a GCD with R, so these two, they were fine. Yeah, how about, okay, what about these two? So these two we know have a GCD, something dividing S2. This one has a GCD of something dividing S2. So these two do as well. And I think it's the same GCD? Maybe. I don't know. But anyways. Ooh. And then it continues. Okay, what about if we had QR minus D1 and TR minus D2? So what's the thing here? So you want TR minus D2 to have a GCD with QR. And QR minus D1 to have a GCD with TR. Or we can choose specific guys that we can make Q and T special, I guess, in some way. And we can make it oh my god. Man. How about D1 plus S1 divides QR plus S1? Along with S1, of course. And D1 plus S1 plus S2 divides QR plus S2. S1 plus S2 along with S2. Along with no, not necessarily. Oh my god. Oh my god. This is kind of messy. I'll just move this somewhere else. Like I'll move this here. Am I missing something in the question? Suppose that for all positive integers n, the number an plus 1 is the smallest integer greater than an, such that the GCD is more than 1. Prove there exist T and L such that this relation is true. I was wondering why we used CRT if we're given the smallest positive integer. No. So I was thinking of, we haven't used CRT yet, But I was thinking we can use CRT to construct a nice queue that would just break the problem open. That was my line of thinking. Okay. SQ, SQ minus 1, SQ plus 1. I don't even know what she's saying because you're foreign. Yeah, she. My days. Okay, let's think. What could we try? Well, we're kind of tunnel visioning on the QR plus 1 idea. We're kind of locking in on that, and I don't know if that's necessarily a good thing. Maybe it is. No, it's got to be. Come on. Okay. So we could use the fact that every one of the remainders, so if we have QR plus S, I've used S already. Let's go QR plus Li. We have Li is shares prime factors with R. So since R is rad A1, let's A1 have K prime factors, and as it turns out, we actually have 2 to the K minus 1 possible Li. But I don't see how that's useful yet. This is soul crushing. Rad A1, just writing, just typing. Yep, this is not fun. Is the GCD always a prime number? No, I don't think so. No, it's not. How to improve proof writing skills. That one really is just writing as many proofs. Reading other people's proofs on AOPS in the IMO shortlist. That's all very useful. Q times R. Okay, so we got Q times R and Q plus 1 times R. Let's try another small case. Maybe small cases really are the key. 21, 24. Now it can be 3 or 7, so 27. Now we're cooked because this is 3 cubed. So everything has to be a multiple of 3. So if we can force... No. No. I mean, I was thinking like, let's say you got 15, 18, and 20. So I don't... Yep, don't... Nope. Oh, tears not tough. Okay, let's go back to the drawing board. Go back. I feel like it is some infinite PHP. There's always some nice thing like that. We had a better sequence, I think, actually. back over here. So we started on 15. Okay, we'll go here and we'll type it out somewhere here. So we started on 15, we had 18, and 20, then 24, then 30. Then it was 30, 35 doesn't work, so 36. Then it was 37, 38, 40. And then it was 42. Then it was 45. So it does repeat. It does take the same time, I guess. 45, now we can go to 48. We can go to, from 48 we can go to 50, nice. That's very similar pattern going on. From 50 we can go to, so no, all of these have, any pair has a GCD less than, something in common that's less than R. So I think that is true, and that's something we need to prove. 50, then we can go to T1 doesn't 54, then it has to be 60. So yeah. Like, because 2 also appears, and the things actually cycle when it's 2 times 3 times 5, not just 3 times 5. So if we take P as product of all primes, P is less than R, then it would be Q plus P over R times R. That makes it work. If we start with A1 as QR, now that's my hunch. Because look, if we have Q plus QR plus P, and we want to find what the thing with GCD is, and then we go from like, so A1 to A2, then that value, yeah. So just repeating it works, but we have to show there's nothing less. So we start with QR, and then we go QR plus D1. So note that also QR plus P appears, and QR plus P plus D1 works because QR plus D1 is congruent to QR, because the two stuff are congruent. But if there's something less, like QR plus P plus S that works, then it must be QR plus P. So then why wouldn't this have worked earlier? Yeah, why? That would have worked earlier if this works. Because yeah. Yup. QR plus D1 plus D2. And again, this is LP. Like I said, that as if this LP, so D1 works because everything has a no, but see, this is where we need to show. Yeah, okay. So we got that if LP plus S works and S is less than or equal to D1, then it follows that, how old am I? I'm 17. If I'm at the start of year 11 and just started BMO papers, am I behind? Nope, not at all. I was wondering why we use CRT if we're given the smallest positive integer. Don't know. Wait, sorry. My brain is AFK. Why we're using CRT? I've already read that, I think, some point back in the stream. I'm just tweaking now. And S is less than D1, then these two have a GCD, so it follows that we should have had S here. Yeah. Yeah, nice, nice. Nice. Okay. So now it just remains to show that, because the issue we could have had is we want QR plus LP plus D1 to be a working value, which means that we need all the GCDs have a prime factor less than R. We've now reduced the problem to this. If we prove this, we're done. We finished all of the questions from the IMO. IMO day 2. So we just need to prove it. Oh my god, my eye is twitching. Too locked in today. Main claim. All the GCDs have a prime factor less than R, but that's really hard. That seems really hard to prove. Man. Is there a counterexample? Or actually, no, if we just prove that the prime factors, you know, kind of India, where are you from? Yeah, I'm from India, that's right. Man. Do you find if you have a talk tomorrow or something, you can have, yeah, I'm fine. Lorraine, do you recommend using Claude for the Beamer one? Beamer, no, Claude will be good for that. Claude will be good for that. On LinkedIn, of course. The prime factors. Of GCD are bounded. How do you sound like that? Because I grew up in UK. Like, I'm from India, but I've lived my entire life pretty much in the UK. How much time should I be taking? I don't know about AIME. Sorry, man. I don't know. But yeah, let's look at another sequence. If we can start on 35, and then from 35 we get to 40, and from 40 we get to 45. Oh, 42 actually works. That's very nice. From 42 we can't get to 45. So can't get to 45. We can't get to 48. Get to 50. Can get to 50. So that's what we do. 49 doesn't work. So yeah, GCDs pairwise, you can see they have a bounded prime factor. From 50, we can get to, can't get to 52 doesn't work, 54. So now it has to be even, I guess. Because if it's odd, well, the 105 works. If it's odd, it would have to be divisible by 35. 56 works. And from 56, we can get to 60. From 60, we can get to... So we just want to make it to 70. That's our goal. From 60, we can get to... Can't do 62. Can't do 64. Can't do 65. 66. So 70. Yeah, nice. And yeah, you can see all of them have a GCD that's got a small prime factor. Yo, bro, do you think Mikhailo Sidorenko still cooked? From what I heard, the UK team, so one guy solved all three, Alex, and the rest of them got 4 and 5. That's what I heard about UK team. I think it comes down to partials a lot because right now I would say I'm just probably glazing my work, but my work is probably worth a fair bit of partials. Like if I just prove bounded prime factors, I'm done. So, and I think a lot of the UK team would have got to this point. And the fact that they didn't solve this makes me believe it's quite hard. What's my medal cutoffs guess? It depends on how hard this question is. But yeah, so I've heard, I think gold will be like 20, 29. Silver, silver's tough because, you know, P5 was easy. Too easy for P2. But P2 was found to be way too hard for P2. Silver, I'd say like 25, I guess, because, you know, I don't think construction on P3 is that bad, and this progress as well is not that bad either. Bronze, 16, like what it usually is, I guess. Bronze might be like 21 actually. If last year was 3 solves, I think bronze 21 is fair. So yeah, 21, 24, 29. You heard it here first. Or actually, wait a minute. No, that can't be right. I have a different solution for P5. You replace x by f of x and get the function as continuous. And then you can get a contradiction for the two different periods. Yeah, sounds tough. Oh, that's really nice. That's nice. That's nice. Yeah. Smart. Proof. Come on. Actually, wait. Do we even need that? Because if we go, so we start with QR, QR plus D1, QR plus D1 plus D2, and then we get QR plus, so all the way up to QR plus P minus D whatever, and then we get QR plus P, QR plus P plus D1. So if that doesn't work, then there's something here that doesn't make it, that makes it fail. And yeah, what could that be? Whew, man. So if then there is some prime dividing something here that doesn't, so Q divides this, and yeah, that is something. Bro, I didn't understand these, but I trust you. Yeah, man, you gotta you gotta trust the process, that's for sure. What is YouTube? Oh man. Poor guy is doing the IMO. Like they'll probably have solved like question 4 and 5 really quickly, and then stuck on this forever. Is it just me, or the jump SMC to BM1 is kind of crazy? In recent years, yeah. I mean, in general, I guess. Yeah. He got 53 mil once, so it's super easy for him. I wouldn't say it's super easy. Finding problems. Close orange. In which college you'll go to, bro? I'll let you guys know next year. Are you a genius? No. No, I'm not. Tell you what I am though, I'm tired of this stupid ass question. That's what I am. How do I open the stream in the background? Chat, what grade is he in again? He is in I guess like it's year 13 in the UK. Going into year 13. I don't know what grade that corresponds to. Some feeling. QR, whatever, bro. If this doesn't work, then there is some prime that divides Q. That's like bigger. So Q, or maybe we can take the primes that, so like primes that divide GCD, AI, AJ, take their products, prove that it grows small enough so that at some point we can take P. But yeah, so what I'm thinking is instead of letting P be the product of all primes less than R, you could let P be the product of all primes that divide any term in this. And show that eventually you get something like, sorry, P is the product of, it's a good way to do it. P is a product of smallest prime factor in GCD AI AJ. CLS. Lorraine, would you recommend? I think you asked that before. Bro, I find JMass very messy. I think you just gotta stick with it, honestly. Do you play any video games? No, I don't. Are you going to IMO next year? Well, that's the plan. That's the plan. Nothing's ever a guarantee in life. Nothing's ever a guarantee. There we go. Will you do any live solves of easier papers? Yeah, maybe. How does the qualification process work in the UK? Well, I actually have a video on that. It's my most recent, yes, SMC to BMO2, Trinity Camp to final selection. Bro knows. Bro knows. Okay. Literally all we want is for GCD. So, yeah. I don't know how you can... I think it's safer to prove that GCD is bounded. GCD, AI, AJ has prime factors that are smaller than R, which would imply that GCD, AI, AJ, GCD, AI, oh my days, AI, AJ, R is more than 1. That's what we want. So can the problem be strengthened? Sorry, no, P actually. Strengthened to this condition. Maybe consider the first such pair. So the first one, A, M, A, N, that doesn't satisfy that. So that has some prime factor that's bigger. P is bigger than R. So we could find some interval. We can find lots of intervals actually. So that, let's go formula. QR, so in QR, Q plus 1R, we don't have a multiple of P. So then we look at the parts which are not coprime to P. So this would be, let's say it's RP, this would be, we use R, so let's say it's TP, and that would be SP. You gotta have stuff that's multiples of T and S. Yeah. Multiples of T and S. That's right. Ooh, my days, my days. Oh, my days. Still finding Pink Kangaroo hard. This holiday I'm locking in, so hopefully I get into Beamer 1 this year. There you go. I'm glad I could help. Okay. And this means so if AM equals TP, AN equals SP, P is more than R. Yep, P is more than R. Sam is more than N as well. So this means that, so T is, okay, we should also say there's some bad part we don't care about. So if we can take this to be the minimal, then it follows that GCD AM minus I AN is, and with P is more than 1, and GCD AM AN minus I is more than 1, and P is more than 1. My days, it's brutal. It's bad to sit down and just do maths. You got to keep on walking around, get the blood flowing. But the blood is not flowing right now, as you can see. We haven't done that much work on it. I don't know what I've been trying. Oh, SPB2. TPB1 SP B2. So linked up by P and default TS. High tech type shit right here. Let's do it. Take me to the IMO with you, bro. when I make it. Yeah. And importantly, it means that S and T are co-prime. Yeah. So T is like the stuff with prime factors less than T is the stuff that's not co-prime to big P. So I actually call this Q, lowercase q. S is the stuff not co-prime to big P as well. So if the only link is through P, then it means that GCD TS equals 1. So in everything, you got like a little bit from T and a little bit from S, and all the stuff that comes before it. So I mean, yeah. Yep. So like in AN minus 1, you got a little bit from T, like some prime factors from T. A divides T, and some prime factors from S. And the same with AN minus 2, AN minus 3, and so on, right? You got a little bit of this, a little bit of that. Which means it's weird that we just get pure S and then we get pure T. Like that's just not right. All right, bet. Do do do. Okay. So we got T P B1, S P B2. Have I ever done have I met Alex Tree, and how close would you say I am his level in Maths Olympiads? Okay, I met Alex Tree, and I, or anyone that I know, is not even close to that guy when it comes to maths. Like there is no one in the UK who comes remotely close to how good he is. Have I done a physics Olympiad? I did BPHO. I did okay. I got like 42 or something. Does further maths A level even help with Olympiads? I think the year 13, the ad math stuff helps with Olympiads. Okay. Was good, man. Thanks for joining us. But yeah. So if we got this P right here, .42 is insane. I mean, nah, it was out of 100. I don't think 42 was that insane. What book did I do to prepare for which one? Which one are you talking about? for IMO or IMO qualifier. Not many. I did EGMO, that's for sure. Bro, that journey to IMO vid was top tier. Thank you, man. Thank you, man. Rade edit or making another video for your series? Do I know you? Do I know you in real life? Yeah, the Rade edit kind of had me questioning. Where'd you get that one from? I see, I see. Alright. Okay. 1.5 hours left. Boom, in 3 hours. And 2 of them have been on question 6. I think this is a pretty hard question. But we've got... I think this is definitely the hard part. We want to show that GCD, AI, AJ, GCD, AI... So this has a bounded smallest prime factor, but in other words, we can show it's p I'm gonna show this is more than 1. Using all 4.5 hours is better than a fake solve. Yeah, absolutely, absolutely. You don't want to be that guy who walks out the IMO like 1 hour early and you realizes he's fake solved like question 1, question 2, and question 3. So yeah, always in any exam, any Olympiad, never ever walk out early. Always stay until the time's done. Yo, can you make the handwriting a bit neat? Yo, I'm doing what I can. Oh hey, you're streaming. How the fuck have you done 3 hours in a row? Don't you get headaches? No, I actually have a headache right now. But you gotta push through it. It's easier when you're in contest because the adrenaline takes care of, how your body feels. But right now it's just painful. So yeah, we had AI has summing P and AJ has summing P. Wow, that's crazy, dude. What's up? P is more than R. Okay, so everything in So yeah, that's a good thing to note actually is that KM K yeah, so KM K ooh. Am I Tamil? Yes I am. Is 2K subs. Let's see. Hey, we're actually 2K subs. Thank you guys. It's all down to you. You've been watching me long enough to know I'm a good mentor. My day 1 viewer. Back in the trenches when I was doing the PowerPoints and doing everything in one take. I respect that. Did Alex Troy sweep IMO? Yes, he did, which is nice because That's his last. This is his last IMO, and he's ending on a perfect score, which will be very, very fitting. Okay. Anyways, so KM is something that would work, something that would fit our criteria. Dude, how much time it took for you to get to this level? Um, this level, I think, it's been 4 years, 5 years. Why? No, sorry, I didn't. I didn't mean to ignore you, man. What are you saying? Okay. Um. So in particular, M has a GCD with everything here because we're looking at the smallest such pair. So M has a GCD everything there. Sorry, man. You know about IMO? Yes, I do. What do you want to know about it? So we can actually, ooh. So just straight M appears. M has to appear. Why? Because if it doesn't, then all of these guys have a GCD with M, but M hasn't appeared. Wait. Okay, guys, let's check this. Let's check this. Dude, I wanna crack it so bad, but this JE culture in just keeping me hostage, bro. Yeah, that's a tough dilemma, man. Are you in mods? Yes, I am. You been to Memo? No. Is it too late to start at 16? Absolutely not. I know guys who started at 16 and they're in the IMO team this year, which is crazy. And yeah, that's what I thought answered. But guys, stay with me on this one. I think I've proved the claim, but we need to check it. Because yesterday, I fake solved. That was really embarrassing. So I'm not doing that again. P divides, so claim is that GCD A1 AIHA P is more than 1. Okay. And the thing is, suppose not. Then it follows that AI equals KQ, AJ equals MQ, where K and M are co-prime. Ooh, nah. Nah. Where GCD KMP. So I don't, nah, see, that's what you gotta write up. KMP is equal to 1. There is no, yeah, and Q is more than R. Then, then what? Then, so GCD AJ minus 1, ooh, must have some good, hang on. Okay, so let X be the product of all primes less than R dividing M. Yeah. Essentially, so we have GCD A I minus anything, AJ, is, and P, because we're looking at the smallest such pair, right? I minus D, AJ, AP. We have that it's more than 1, so GCD AI minus D, AJ, X is more than 1. So if we can find X, oh, I thought I had it. Man, that's rough, that's rough. But I think I'm close, So my idea was we can find the smaller term. Initially I thought you can just say, oh, M is in the sequence. But if A1 is more than M, then it's difficult. Wait, but so Q is more than R. Okay, but actually if we take the bounds, no, wait, so okay. We want to say let M to the D be in the sequence. But if A1 is, so A1 is more than M to the D, and AI is less than M to the D plus 1, we have C to D. We can't make this work, actually. Can't make this work. So we want AJ to be more than M, AJ to be more than M, A1. And that would stop this. So instead, if we set P, so we're looking at Q is more than A1. P is product of all primes less than A1. Then KMP equals 1, Q is more than 1. X be the product of all primes less than A1, dividing M. That we don't even need that. So we want MD to be in the sequence. MD, M to the D needs to be in the sequence. But A1 is less than Q, so AJ is more than MA1, which means there is a power of M in the sequence before AJ, because it can't be skipped. Wait. Because it can't be skipped. And I think that's it. That's so overwhelming, though. Okay, look, so I'm certain this is right. This is the way to go about things. But then does it imply we're done? Need to check that again. So I think this is the end. This is the end of it all. Claim if true. I guess if true. Sorry, no. We are done. A claim, we are done. That's the claim. The proof is, well, we start with A1, which is now it's Q times R, right? So yeah, if we go if we start with QR and QR plus D1, and instead now we go to QR plus D1 plus D2, and instead now we go QR plus QR plus P, where P is our new definition, QR plus P plus D1. That has to work because it's congruent under all like good primes. QR plus P plus D1 plus D2. And if that works, then the rest works. And we can repeat the logic for, come on, give me some. QR plus LP, QR plus LP plus D1, QR plus LP plus D1 plus D2. Now we can repeat the logic. We showed earlier that if this ends up being like LP plus S, then we should have, replaced D1 with S. Should have done that. But it is what it is. And yeah, so the sequence of differences is periodic once we get to adding P, which means that we are done with the IMO Day 2 Livesolve. Question 4, done. Where's the score stuff? Here it is. Question 5, done. And question 6, also done. And yeah, thank you guys for watching. And I don't know when I'll be live next, but if I'm not live soon, then I'll see you in the next video.